Are we going to keep talking about contamination, children?
Yes.
Yeah. All right, so this is fractions. We're still doing this. I want to get through this stuff quickly. I'm going to do this. Hopefully this video will take up, well, most of these. So first one we're doing is evaluate 1 2/5 minus 3/4. What's the first step? Well, what's the first thing you think of when you're looking at fractions and you're adding or subtracting them? They have to have the same denominator. Okay, have these got the same denominator? Okay, so straightforward, you need to change the denominator. Now, to change the denominator, what are you going to do? Okay, so you guys are just going to like cross multiply basically.
Yeah.
Okay, and do the left one times 4 and the right one times 5. Okay, that's the easiest way. It's not always the quickest because you can use the lowest common denominator that they both go into. In this particular case, the first number that both 5 and 4 go into is 20. So cross multiplying is easy enough. If it was 2 and 6, you'd just change the one that was over 2 to 6. But because 2 goes into 6, so you could just times the 1 over 2 by 3. That make sense? Okay. So anyway, on this one we're not. Now the other thing is we have a mixed numeral. You guys remember what a mixed numeral is, I'm assuming? You have one whole number and then a fraction. So you can do it one of two ways. You can convert the mixed numeral after, or you can convert it before. Doesn't matter, but I would always recommend changing it to an improper fraction. Much easier to deal with. Okay, I don't mind whether you do it before or after. I have a tendency to do it before, just because I don't like mixed numerals. I much prefer improper fractions. So I'm going to convert it to start off. Cool? So I've got 7 over 5 minus 3 over 4. I'm going to times this side by 4. I'm going to times this side by 5. Cool?
How did you get 7?
1 2/5. Because one whole is made up of 5/5. Imagine you had a pizza. She's the UK chick. Imagine you had a pizza and you cut it into nothing. Nothing at all. Imagine you had a pizza and you cut it into 5 slices. Okay, one pizza. How many fifths would there be? She's drawing. For you guys on the electric internet, she's drawing the picture. You don't know the UK chick? I'm going to let you look it up, but look up UK girl. Was it Pizza Fractions UK? But not now. I don't know her name. I hope she doesn't actually have one. Okay. So, one pizza, how many fifths? Cool. So we've got 5/5 in that whole number, plus another 2/5. So how many fifths have we got in total? No, you just made them small. Fifths have to be the same size as each other. And you only eat 2 of those. So you ate 5/5 of one pizza and 2/5 of the other. What have you got? Belly. Awesome. Right. Wasn't expecting that bit to take so long. So, okay, what do we end up with? Now, when I do it, I'm actually multiplying it not by 4, but by 4 over 4. Does that make sense? What is 4 over 4? 4 over 4 is 1. So I don't want to change the value of the fraction. Okay, if I have one pizza that is 5 slices, okay, it's divided into fifths. I don't want to change the value of that, so all I'm doing is cutting them into smaller slices. Instead of fifths, I'm now going to have 20ths. So each one of those fifths, I've cut into 4 slices. Does that make sense? So by timesing it by 4 over 4, that's the same as timesing it by 1. Most of the time when I say it, I wouldn't say that I'm timesing it by 4 over 4. I'd just say I'm timesing it all by 4. Okay, but I end up with 28 over 20. Okay? So what I've got is each one of those 7/5 I've cut in 4 times. So I now have, for each one of those 5, I've got 4. So that's why I get 28 over 20. You'll notice if you simplified that, you get back down to 7 over 5. Is that all right? So I haven't changed the value. I've just changed the size of the slice. Cool? And I do the same with this one. I've timesing it by that, so I end up with 15 over 20.
Having 5 slices, you get 28.
Yeah, but they're much smaller slices. They're a quarter. Yeah, exactly. You're not the UK girl anymore. Well done. That's exactly what the UK girl is about.
What's a UK girl?
You watch the video, yeah. You watch it, it's go, ah! I'm hoping she's an actress. I'm honestly hoping. What?
Just shut up for a second. We're listening.
Yeah. So I haven't changed the value, okay? Everyone happy with that? Yeah. Okay, so now we've got 28 over 20 minus 15 over 20 gives us 13 over 20, and we simplify it if we can. Cool?
Can you simplify that?
No. 13's a prime number, so that's always a giveaway. Mewit's broken. Mewit's broken. All right, so most of the time I won't write 4 over 4, but that's what I'm doing. Does that make sense? Because I don't want to change the value of that. I just want to change the size of the slices. Okay, I want the slices, because I can't add or subtract them, because the slices aren't the same size. Like if you had a pizza that was cut into 4, and your mate's got a pizza who's cut into 5, and you want to swap some of the pieces because they're different pizzas, the dude with the quarters is going to say, no, yours are smaller than mine, man. So you have to cut them to be the same size. The only way you can cut a pizza that's originally cut into 4 and a pizza that's originally cut into 5, the only way you can make those slices exactly the same is to cut them into 20s. So this is a practical problem for you guys who want to share pizzas. Well, I'd just like to find the pizza place that's cutting them into 5 slices and slap them. Because it's awkward to share. 4, 8 normally. Yeah, you always do it in multiples of 2. Always do it in multiples of 2. You go half, quarters, eighths, 16ths. Halves. Dude, you don't do that. No, you made a basketball. Serious. Yeah. No. I'm going to say yes, just so you can finish the story.
Do you know how many
because you were shattered. Do they? Or is that a question? Because I'm not going to be able to help you out here. 12. 16 would be normal because it's it's a power of 2. Whenever you're doing that, you're normally going to do it as powers of 2. You're going to go, you do it into 2, you do it into 4, you do it into 8, or you do it into, oh my God, they're small. 16. Yeah, my drawing was bad. All right, continuing on. We've got to keep going. We've got 2.5 divided by 3. How do we do it? Yeah, cool. I've also got an improper fraction, a mixed numeral there again, and I don't like mixed numerals.
So it would have been 3.
Yes. No. 5 over 2. Yeah, no. It would be 3 over 1. And we've got divided. How do we divide fractions? We could do it with a calculator, but I'm asking process rather than numbers. What do we do? Invert and multiply. We did this last year. Yeah. Flip, invert and multiply. Okay. Now you just do it. Nah, you only invert the right-hand one. Okay. You would get the wrong answer. Correct. Why would we? We've gone 5 times 1, 2 times 3. Wow, I can't do 2 times 3 anymore. That's better. Thank you. My bad. All right, everyone happy with that? Okay, when dividing fractions, and even if you're dividing by a whole number, it's basically, as Jesse said, it's a fraction, 3 over 1. Invert and multiply. Cool? All right, next one. Evaluate 0.056 times 100. This should be very, very easy.
5.6.
Killing it.
1, 2, 5.6. Now, be aware that if it says to 2 decimal places, then you've got to add a 0. If it says to 3 significant figures, you need to add a 0. Okay, just be aware of what's going on in the question. But in this case, perfect. Sorry? It's not unless they are. Oh, it gets a bit complicated. Yeah, it's not. But at the moment, you've only got 2 figures. So that would be a third significant figure, even though there's nothing there.
Can you add a 0 in front of the 5?
Yes, but that means nothing. Like literally nothing. It does, but if they've asked you to do 3 significant figures, that's what you do.
So you can write 0, 0, 0, 0, 0, 5.6, but that would make
That's still the same answer. That's still, it hasn't changed because as Milt said, we haven't added anything. Still nothing there. If there's ones, then that's completely different. Okay? But when we do significant figures, you'll see that. Okay, evaluate 0.02 times 0.3. Ignore the point after the 3. It's a full stop. Okay, 0.02. What do we do? Just ignore the decimal points. What's 2 times 3? Cool. How many decimal places do we need to have in the answer?
2.
We need to have 1, 2, 3. So we have 3 decimal places. Okay? Because you've got to remember, when you're timesing by a decimal, you're timesing by something that's less than 1. If you multiply by something that's less than 1, you make it smaller. Okay? It's a fraction of it. It's a part of it. All right, next one. 8.753 divided by 10. Which way do we move the decimal place this time? Left. How many places do we move it? 1, because it's dividing by 10. If it was dividing by 100, you got 2 decimal places to the left. We've got a decimal system. The amount of zeros that you're timesing by, like 10 is 1 0, 100, 2 zeros. You're just moving the decimal place. All right. Next one. This is the price of a $75 tennis racket increased by 5.5%. Find the new price. There's a couple of different ways to do it. How are you going to?
Yeah, go 75 times 5.5%, and then add the answer to the 75.
Okay. 75 times 5.5%. Everyone do that. What is it? Let's go 4.125. That's fine.
And then you add that onto the...
It would be 799.
You will in a minute. Okay. 79.13. Cool. Everyone happy with that? Can I show you another way? All right. We need to add it by 5.5%. We need to add 5.5%. Increase it, right? So we've times that by 5.5% to find out what 5.5% of it is. Okay, so we did that. That's how much it was, $4.125. So $4.13. We added that to the original because we're increasing it by 5.5%. So we added it to it. If it said decrease, we'd take it off. Cool? Yeah. Now I'm going to show you a quicker way of doing it. What's $75? That's how much of the price? 75%, $75, sorry. $75 is how much of the price? It's 100%. And we want to increase it by what? Times it by 105.5% because I've added 5.5% to the 100%. So times that, do that on your calculator and you will get. Now, if I wanted to reduce it by 5.5%, I would have to do 100 minus the 5.5, which would make me 95.5%. Close. I was close. It was pretty good for me. I was going to say 96.5 originally, and then thought, no, that'd be stupid. And then still got stupid. Yay for me. Does that make sense for everyone? Oh, I know, so I'm going to hit stop. Isn't that awesome? We saved.
What's that on your computer screen?
But I've only got, it's, no.